Welcome back to day 2 of the FAA's 2020 International Rotorcraft Safety Conference. I am Stephen Barbini, Manager for the FAA's General Aviation Rotorcraft Unit. Today, our focus is on maintenance. I want to remind you that we are offering wings, AMT, and IA credits for many of these presentations. If you haven't already done so, to receive credit for IA refresher hours, enter your email address in the Zoom Q&A box, not the chat box, the Q&A box. For wings and AMT credits, enter the email address associated with your FAAsafety.gov account into the same Zoom Q&A box. If you have audio difficulty, you may want to dial in along with logging into Zoom. Attendees using phone dial-in without logging into Zoom will not receive any credits. Now on to the show. Our first seminar will be presented by David Horton, President and Managing Partner for Schweitzer RSG, the 269 series helicopter's original manufacturer. Schweitzer RSG acquired the type certificate of the 269 series helicopters from Sikorsky, a Lockheed Martin company, in January of 2018. Prior to this transaction, David is credited with improving the support and profitability of Schweitzer helicopters. So David, I give the show over to you.
Stephen, thank you very much. Thank you for letting us be a part of this important presentation. We understand that sharing this information is imperative for all of us to foster a safety-first environment in the helicopter industry. Let's go ahead to the next slide. This is just a quick rendering of future production of the 300C helicopter. We'll talk a bit more about the avionics and navigation equipment here shortly. Next slide, please. Quick agenda, we'll talk real quickly about the crash-resistant fuel system with an update. We'll talk about some of the airframe updates that we just viewed just a second ago. Talk a little bit about the website and its the things that are available on the website for maintenance technicians to use. And then we'll get into the heart of the maintenance presentation. We'll start with the lower coupling drive shaft, and the reason for the lower coupling drive shaft is the 150-hour requirement to do non-destructive testing. We are working with the FAA through our continued operational safety folks here at the ACO in Fort Worth to extend that time, but we're also looking for help from our operators in the field to give us information about what they're seeing with regards to the lower coupling drive shaft. The next subject we'll talk about is pitch bearings. Pitch bearings are really critical in order to get a very smooth flight and longevity of your hub of the 269. So we'll talk a bit about the maintenance and stack-up procedures of bearings. We'll talk very quickly about tail rotor pitch control, bearing inspection, namely the newer style of bearing that we produce on new helicopters today. We'll talk real quickly also about the main rotor damper attached bearings. And then we'll follow up with the tail rotor drive shaft inspection and carrier repairs, things that we have seen in our management of the business over the last 12 to 18 months. Next slide, please, sir. So our crash-resistant fuel system, we intended to be completed before April 5th of 2020. It's been delayed a bit due to health concerns, both for us here at Schweitzer as well as the FAA here in Fort Worth. We are on track to finish this important project before the end of the year. I think the most important portion of this slide is that the crash-resistant fuel system is upgradable to the older 269 helicopters, specifically the A, the A1, and the B, as well as some of the older C models. As we finalize the certification of this important development, we will be able to publish a service letter that shows the 269 operators how to actually acquire a kit where the crash-resistant fuel system can be installed on your helicopter. Next slide, please. So we'll talk real quickly about the airframe updates. We're going to come with the future production of glass panel. I think the most important part is electronic digital flight instrument systems, which we will display navigation, pilotage, helicopter systems, including rotor and engine tachometer, manifold pressure, things of this nature, where we have a fully digital presentation with regards to the helicopters, both the operational characteristics or operational information, as well as pilotage and navigation equipment. We're doing this for a couple of reasons. One is we want to upgrade our airframe and get it more into the 21st century. The second most important part is we're going to be able to include some safety features in this installation, specifically with overspeed warning, recording systems, things of this nature that will limit or eliminate some specific incidents that could happen while operating the helicopter, and also provide good maintenance history so that our maintainers will be, well in tune with what our helicopters are doing in the field. Next slide, please, sir. Our online presence, we do have the Schweitzer website up and running, and I think the most important portion of this now is that our maintenance publications, specifically technical publications, service letters, service bulletins, you can find those on our website, as well as flight manuals and flight manual supplements. In the future, we want to be able to expand our online presence to include part sales and other things for for the support of our helicopters in the field. We believe this is really going to be more relevant as our fleet grows. We already have a presence of the 269 helicopters around the world. Being able to show our wares and be able to support our customers via the internet is going to be more important than ever, so that everybody around the world gets the same level of support. Next slide, please. So here we're going to just rehash what our technical briefing is really going to be, really entail. Again, the lower coupling drive shaft, pitch bearings, main rotor hub pitch bearings. Talk quickly about the tail rotor pitch control bearings, main rotor damper attached bearings at the pitch case, and tail rotor drive shaft inspection. Some of the things we found and some of the things we intend to issue a service letter or service information letter in the future. And then we'll finish it up with some of the carrier repairs that we've been able to accomplish here at Schweitzer. Next slide, please, sir. So in many cases, we've seen improper installation or the spacing of the components of the lower coupling drive shaft, and this has caused a failure of the grease retainer and the boots themselves. And this obviously makes a mess of the helicopter as the grease is slung around within the engine compartment, but it also allows the introduction of things like water and dirt that you do not want in the mating surfaces of the lower coupling drive shaft, either where it goes into the adapter attached to the front of the engine, or the shaft that drives the lower pulley. We're also going to talk a bit about overgreasing of the engine adapter. That will also cause premature failure of the boots. And we'll revisit the HMI inspection and maintenance, specifically to talk about the amount of grease used, the alignment of the retainer ring and the alignment ring. We'll also touch on some of the things we've seen in the field where very ingenious maintainers have developed their own tooling in order to be able to install these new components in the field. And again, this is really an important subject these days, due to the requirement of the 150-hour NDI inspection. Again, as I spoke about during the first part of the introduction of the presentation, we are asking our service centers and our operators to be able to provide us information on what they're seeing with the lower coupling drive shaft in the field based on the results of the NDT inspections, so that we have a solid history to present to the FAA that would allow the inspection period to increase from 150 hours. Initially, we'd like to go to a 300-hour time frame. That coincides with some other inspection requirements in the 269, but we'll have more about that on our website in the coming weeks. Next slide, please, sir. So here's a quick note, excerpt from the 269A, TH55A, A1, B, and C basic helicopter maintenance information manual, specifically section 10. And I'd like to call your attention to notes number 6 and number 8. So note number 6 is really talking about the alignment ring. And once you get the alignment ring situated on the shaft closest to the engine, where the shaft is inserted into the engine adapter, it's important that you keep about a 1.75 inch distance from the end of the lower coupling drive shaft and the beginning of the alignment ring. It's also important to know that you need a couple of wraps of 032 lock wire to keep this alignment ring in place at the specific location. The other thing that I would call your attention, the other note that I would like to call your attention to is note number 8, where it says position the retainer ring is shown. The retainer ring is the ring closest to the end of the lower coupling drive shaft that will insert into the lower pulley coupling shaft. And so there's a couple of things we need to be mindful of on this retainer ring. Is one is secure it with contact cement, which is listed in table 2.2. I didn't show you the table, but there's a complete table of materials and chemicals, adhesive, that sort of thing in the front of the maintenance manual. Those kind of things are listed there, and it identifies what we're asking you to use to seal that retainer ring on the lower coupling drive shaft. In addition, we're also asking that you install a couple of wraps of 032 lock wire, much like you did with the alignment ring, and make sure that we pay real close attention to the distance from the end of the lower coupling drive shaft. Should be 0.6 to 0.4 inches from the end of the lower coupling drive shaft. If you pay attention to these small details when you're reinstalling the lower coupling drive shaft, your chances of having any issues between inspection periods will be greatly diminished. Next slide, please. So here's some tips for the installation of lower coupling drive shaft, rubber components specifically. As we talked about, in the previous slide, the retainer ring, the boot, these things of this nature, the alignment ring. We have found that the best way to install these components is to lubricate both the shaft and the component with a Dawn dishwashing soap. Other silicone lubricants, they don't work nearly as well as Dawn dishwashing soap in it. And also with the Dawn dishwashing soap, you can clean it up and get a clean surface before you do the final installation. The other thing that's super important here is that once you've repainted your lower coupling drive shaft, make sure that the paint is dry and there's no tackiness to the paint, because that will inhibit the correct location of the components that you need to install prior to the installation of the lower coupling drive shaft. There is one other way that we can actually install these rubber components, which would be boiling water, and then that would loosen up or add additional pliability to these components before you put on the shaft. But I think overall, the majority of people that we talk to in the field have said that the Dawn dishwashing soap actually works the best. Next slide, please. This is a quick picture of some of the work aids that some of our maintenance technicians in the field have developed that will allow the easier installation of the various components for the lower coupling drive shaft. Our engineering team, they are looking at these various phenolic or plastic pieces that have been designed, and we're going to try to come up with our own standard work aids for the installation of the rubber components. What it does, and it's the whole idea of these work aids, is to protect the rubber components as installed from the teeth on either end of the lower coupling drive shaft. Next slide, please. Grease note. So as we mentioned previously, you can over-grease the lower coupling drive shaft on either end. It's really more critical on the engine side, but both sides are equally, it's equally important to grease both ends the same. So we talk about four full tablespoons, or approximately 2 ounces of grease, and this is spread evenly throughout the teeth, the mating teeth on both the adapter surfaces as well as the teeth on the lower coupling drive shaft. Again, do not ever mix the greases. Once you've gone with an approved grease, please stay with that grease and do not mix greases. If in fact you're going to change greases from one to another, ensure that both cavities are clean and there's no grease residue from the previous installed grease. Next slide, please. So next, we're going to get into pitch bearing inspection, and this is super important for a couple of reasons. One is we want to have the 269 have a really solid, smooth ride, and the rotor hub to be really smooth. And this is one way that you can ensure that you can do that. The other thing is the pitch bearings are expensive, and they are critical to the operation of the main rotor hub. And so a continual monitoring, ensure they're greased correctly and ensure they're put together correctly, will give you a long service life of these pitch bearings. So just a quick overview. The pitch bearings are situated inside the pitch cases. There's actually 4 bearings. There's a tri-set bearing that goes towards the end of the pitch change shaft, and then there's a single bearing that's situated closer to the flapping bolt on the flapping end of the pitch change shaft. These bearings are machine set, and they do rest against the inside of the case where there's a preload. We'll talk about that more in a bit. These bearings do require an inspection, and we'll get into how you should do the inspection. And there's a few little tips that are definitely required, or a few notes definitely required to pay attention to ensure that when you put the pitch housing with the new bearings or repacked bearings together, that it goes together as outlined in the HMI. As a first inspection step, if you've got any either through a normal inspection, or if you've had issues with track and balance or ride issues of the helicopter, you want to be able to pull the cap and check for metal of any metal particles that would be in the pitch change housing, coming from the pitch bearing assemblies. At that point, it renders the bearings unserviceable and they must be changed. Can we go to the next slide? This is a cutaway view of the pitch assembly. And as we talked about before, the triplex bearings are located there towards the end. The pitch bearing grease cap is the cap that I just talked about. With the removal of that cap, if you see any signs of any metal flaking or metal particles, it will render the pitch change bearings unserviceable. We'll talk a bit, or actually quite a bit, about the lock nut and the lock washer and the preload. Also, I'd like to point your attention to the pitch bearing spacer. This pitch bearing spacer is unique to the pitch bearing assembly, and the reason for that is the manufacturing of the pitch bearing housing and the pitch bearing spacer need to be always kept together. If in fact you have one that you cannot get a preload correctly on, or you feel like the pitch bearing spacer is not the correct pitch bearing spacer due to assembly difficulties, you can return it to Schweitzer. Reach out to our tech support team through schweitzerrsg.com, and we can manufacture a new pitch bearing spacer that will correctly align with the pitch assembly. Next slide, please. This is the actual test for the pitch bearing assembly. Once you get it, once you get the pitch bearing assembled, there's a couple of notes. One is make sure that you hand pack the bearings before installation of the triplex and the single bearing into the pitch bearing assembly. We want to go the torque value of the pitch bearing nut on the low side of the torque range. And we want it torqued enough just to ensure that there's no lateral movement of the bearings on the pitch bearing shaft within the pitch bearing housing. Once that's done, you want to make sure that there's a smooth operation. The inspection of the pitch bearing assembly shown on the right here will give you that test, and it should be very smooth. There shouldn't be any ratcheting. It should be a very smooth movement, both to the left, right, 360-degree view on the bearings as they are installed, as installed in the pitch bearing assembly. Next slide, please. This is actually the reason that you want to make sure that you keep enough torque on the pitch bearing nut to ensure there's no lateral movement with the bearings. You want to put just enough preload on there to ensure that there's no movement, because once you get the pitch bearing installed in the helicopter with the blade, you're going to want to do the preload test as shown here with a scale. So preload of anything of 2.8 pounds or less is acceptable. Anything excess of 2.8 pounds is not acceptable, and we either have a bit too much preload on the nut, or there's a possibility that the spacer is incorrect for that pitch bearing housing. So normally if you do it correctly, where you get the correct load and the nut is torqued correctly, you shouldn't have any issues once it's installed in the helicopter to meet this requirement as shown on detail A. Next slide, please. So now we're going to go to the tail rotor pitch control bearing inspection and lubrication. There's really a couple of things that are important here. One is the identification of your configuration that you have in the field of your tail rotor pitch control bearing. There's a bearing that has been superseded, and if we go to the next slide, it'll be easier to explain. The older lower tip speed bearings, where they were pressed into the pitch change housing, they are no longer supported by us, the factory. If in fact the bearing is still serviceable based on the HMI requirements, then you can continue to use this setup. However, if the bearing ever goes bad, then you will have to replace the entire pitch control housing. The current configuration is a double row bearing where it shows the current type in the lower portion of the presentation there, where it actually has the shaft that goes through the bearing and has a lock washer and associated nut to hold it together. This will allow the bearings to actually be removed from the pitch change housing and be re-greased. Next slide, please. So the pitch change bearings that we have in the tail rotor pitch control assembly now, they're both double roll bearings, but there's a couple of different manufacturers, and so one of them has one grease seal, the other one has two grease seals. They're both equally straightforward to grease. The idea is to make sure that when you complete the re-greasing of these bearings, that there's approximately 40, no more than about 40% of the entire cavity full of grease. And so the HMI gives you specific details on what you're looking for with regard to, how much grease you should have in there. And 40% is just where you can almost see the bearings before you reinstall the seals. So next slide, please. We're going to do a quick overview of the Elastomeric damper. These dampers have been around for quite a while. We don't support the older dampers that are oil filled anymore. These are the dampers that we see in the field most often. They are not a repairable item from Lord or from us, but they do give good service. There's a couple of identifications that are a couple of things you need to watch for with regards to these dampers. One is to make sure that the jam nuts and the turnbuckles are all tight whenever the adjustments for the lead lag have been completed and are acceptable. And that's one of the things you're going to want to check, is to make sure that there's no looseness in that setup there. The other thing that's really important is to make sure that the bearings, both on the pitch housing and the bearings on the trailing edge where it's attached to the trailing edge of the main rotor blade, that the bearings are tight bearings. There's not a lot of axial play in those bearings. So that's the things you want to look for the dampers. Again, these dampers have been around for quite some time now. They do give good service, but some of the things that can cause you problems in the field are the attachment at the bearings, both at the pitch change housing as well as the bearings at the trailing edge of the main rotor blade. Next slide, please. On the next couple of slides, I'm going to talk a lot about some of the things we've seen here and that we're working on currently with our aircraft certification office here in Fort Worth. We had a tail rotor drive shaft come to us from an operator on the southeast coast, where the drive shaft exhibited some bubbling on the external portion of the shaft. And so what we found out after further review of the shaft, we found some corrosion pitting where there were holes actually in the tail rotor drive shaft. Serial number was 484. The drive shaft was manufactured in 2008, and it was approximately 60 hours from its retirement life. Again, this part number, the 269A6040-009, it has a retirement life of 6,000 hours time in service. So it was almost to the expiration date. We subsequently cut this shaft apart, and what we found was in certain places, it looked like where the drive shaft had been sitting for a while, corrosion had begun to form. And so there's a couple of things that we considered as we started going through this investigation, the tail rotor drive shaft. We've never had a tail rotor drive shaft ever in 60 years. And the analysis showed that salt to air, or salt specifically, is causing the corrosion. But again, we're not real sure how it entered. I think one of those pictures will show that there was grease that actually impregnated the tail rotor drive shaft, but we don't consider that a factor, as we could not get through a leak check any water or any other kind of substance behind the sealed adapter. So we feel like the grease probably got through there at very early or very late in its operational life. We had one other drive shaft from the same operator that had the same corrosion, although it did not exhibit any of the same external characteristics of the first drive shaft. And then follow on, we looked at 3 additional drive shafts from the same operator and noted we noted no defects via X-ray, and I'll talk about that a bit more in the next slide. So what we decided to do is follow a couple of paths. We wanted to do the inspection of the tail drive shafts based on the location of the operator. We did that. So we've asked this operator to do the inspection of 100% of their fleet. And we're going to stick with this computed radiography X-ray capability in order to determine if there is any corrosion evident within the drive shafts they have in the remaining balance of their fleet. We also have looked at drive shafts that we have here at the factory that have anywhere from 2,100 to 4,400 hours time in service. And as we did the X-ray on those drive shafts, all of them came back negative. There was no anomaly shown within the drive shafts. The picture to the right shows the corrosion that we saw in the one drive shaft that we cut up, and so it's very evident through this non-destructive testing that the corrosion was present, and that it gives us a very good view about what can be done in the field if in fact that we have a customer who suspects that their drive shaft could have some corrosion issues. This computed radiography is it's non-invasive, so you won't have to do any destructive testing on the drive shafts in the field, and it's readily available throughout the United States. Again, we would recommend you stick with somebody that is familiar with aviation products or aviation components to do the X-ray, but we feel like that this is probably going to be the best solution. We will issue in the coming weeks, coming months, a service information letter that during your next tail rotor drive shaft removal from the airframe, do a detailed inspection to make sure there's no anomalies on the external part of the tail rotor drive shaft. If in fact you find anything, we would like to know about it here at the factory, but we also would recommend that you do complete this computed radiography X-ray. If you cannot do that, or if you do not have a location within your operational area to conduct this kind of an X-ray, we would be happy to help you here at the factory to get this done. Next slide, please. Carrier repairs. We had a specific operator within the service center network who performs overhauls on main and tail rotor gearboxes, who found this anomaly where we were experiencing small cracks around the bolt attachments to the ring gear. And let me say that we have 4 overhaul facilities around the world. We only saw this anomaly, or we only heard about this anomaly from one service center, and so anyway, it's not been a widespread issue. We thought initially it may be just the way that the helicopters are operating, or it could be an assembly issue whenever the carriers were initially assembled, or even during the overhaul process. So what we found were the superficial cracks. They're about 7 thousandths deep, so it's less than 2 sheets of paper is as far as the cracks extended. We actually did some destructive testing on one carrier to determine the depth or the extent of the potential damage of the carrier. The other thing that we did with it is to determine the cause of the cracks, and the cause initially, or what we've been told by the metallurgist, is that over torquing of the bolts is what led to the superficial or the cracks as is shown here. What we found then was that there's previously been engineering data and a service letter that allowed us to be able to issue a new service letter that we are able to machine up to a certain depth on the bolt where the heads of the bolt and the washers reside that hold the ring gear into the carrier. And so we've been able to repair 3 of these carriers that have been found, again, from one service center, not worldwide, just one service center. And so we're closely monitoring this situation. We don't believe that it's a widespread issue, but it's something that if your service center comes out and says through the inspection or the overhaul interval of the main gearbox that this anomaly has been found, we would like to know about it, but also be advised there's also a service bulletin that we have issued to allow one-time modification that should get the carrier and the ring gear from the 3,000-hour inspection period or the 3,000-hour inspection period to the end of life, depending on if it's installed on a 269C or a 269C1. Next slide, please, sir. I think I've gone, hopefully I didn't go too fast. This is the data that we have today, and it looks like I've finished quite a bit early. I'm hoping that we can have some great questions and do some dialogue back and forth with the participants. And anything that I do not know, I have been an A&P and an I for 33 years. I've been in the helicopter business for about 28 of those years. But I can tell you that, for the 269 series, there's still a lot that I'm learning, but I'm interested in getting the feedback from the participants, and anything that we can answer, I'm more than happy to respond directly or have our technical or engineering team respond directly to any open issues or any questions that may come up through our Q&A session.
Thank you, David. Provide a lot of helpful information for those that maintain the 269s out in the field. I have a couple of questions came through. They're both related to the crash-resistant fuel system. I'll ask in almost like 2 parts. The first one is, will the new crash-resistant fuel system kits be retrofittable to the existing 269 fleet? And following on to that is, kits be priced attractively to incentivize legacy updates?
Yeah, so thank you, Stephen. Yes, we will be able to retrofit the crash-resistant fuel system to the older fleet. There will be some airframe modifications required, but our intent is to have a complete kit so that the A1s, and Bs that are fielded, it would be a pretty straightforward modification. As far as the pricing, we don't have a finalized pricing, but I can tell you the philosophy of our company is that we would want to be able to competitively price it with not much of a margin in the system. For us, it's more important to get the system out into the field and be able to retrofit the fleet. That's the most important thing for us, as opposed to trying to sell a safety feature that's really it's an enhancement to our our fleet. The idea for us is to not make a ton of money on it. If I can speak a little bit more about that, Stephen, we did some research during this process of the certification, and between 2006 and 2016, the 269 fleet had approximately 1.1 million hours of flight time on it. Out of the NTSB report accidents, so this is just for the FAA or North America, there were 6 accidents that involved the post-crash fire. Out of that 6, 4 of them, the helicopter in question came in contact with high tension wires. The other 2, there's a helicopter that landed in some tall grass and the grass caught on fire. The other one was specifically where the fuel tank became departed from the helicopter after a auto rotation on a hard runway that evidently didn't go very well. But overall, we haven't had a lot of post-crash fire issues. But again, 1 is too many. And so we are very confident that our crash-resistant fuel system that we've designed that, again, will be retrofittable to the fleet will be a big safety enhancement for the 269 fleet.
All right, thanks, David. And let's see, the next question we have. You mentioned doing repairs on carriers. How do you address cracking at the holes? I mean, you oversize the holes, or how's it done?
So if it's a crack within the hull, the carrier would actually be scrapped. The cracks that we're talking about here were superficial cracks where the attachment bolts and the washer or the buildup that attach the carrier to the ring gear, that's where we've experienced this cracking phenomena. And again, it's super important to make sure that when you reinstall the carrier that the stack up is correct with regards to the length of the bolt as well as the washer thickness before you torque the carrier to the ring gear. We've not experienced any cracking within the bolt holes. All these have been on the top surface where the actual bolts attach to the ring gear.
Okay, thanks. So the next question we have for you is, how long does it typically take to X-ray a tail rotor drive shaft?
I think we've had ours done within a day. If you get down to asking me about, minutes or hours, I'm not sure, but we were able to turn ours within a day. Now, to be fair, we're in the Dallas-Fort Worth area. We have a lot of NDT capabilities here. There's a lot of aviation-related businesses in our area, and we're very fortunate to have those. But we had ours done within a day.
I'm on mute button there, sorry. Let's see. Next question, and hopefully I get the question correct. It's pertaining to Dawn Dish Soap, asking about being listed in the accepted materials list, or does it just reference locally procured lubricant?
Reference locally procured lubricant. I knew that I was going to get that question. We're going back and forth with engineering to, have something on there that would approve that. If somebody needs it on their approved list as part of the HMI, but it's a locally approved, agent that you can use to ensure you can install the rubber components correctly.
Okay. Let's see, I got a number of questions here.
Great, I love it. I just hope I can answer them.
Oh, no problem. Let's see. I was going through because some are very similar to the questions I already asked.
Okay.
Let's see. Oh, no, I think everything was covered. Yep, just another question has popped up.
Okay.
Let's see. Can you talk a little bit about the 269 crash in Israel a few years ago and anything that came out of the investigations?
I am not familiar with that crash. So you've caught me off guard a little bit, Stephen. I will go review it. If there's specific questions around it, that would be great. I can tell you that we have studied several in South Africa as well as in the U.S. here, but I'm unfamiliar with that one. So my apologies that I'm not on top of that one, but I'll be happy to look into it.
No problem. Thanks. Let's say I know we need to get to at least 50 minutes here. We have about 5 left. So I'm just going to throw it out just off the top of my head. Any specific functionalities in the new glass cockpit layup you have planned?
Yes, I think the most important thing there is one is that you have a single view for all the instrumentation, and we tried to make it where it's very user friendly. But again, as I said before, the biggest thing is to be able to monitor a lot of the helicopter operational parameters. We have a star system on our helicopter that will prevent an overspeed on startup. That has been it's been linked to, but specific issues with regards to the helicopter drive system. If in fact the engine has started and it exceeds, say, 1800 to 1900 RPM on initial startup, because it's got nothing it's driving against. So that's one of the things that this system will help prevent. It will limit the RPM on startup. We'll also show the actual speed, or record the actual speed on startup, as well as record a lot of other parameters with regards to speed, temperature, and pressure for the helicopter.
Sounds interesting. That was a question from my flight test background. See a lot of glass cockpits coming out, making it easier for the pilots wise.
Yes. The other thing that I think we haven't finalized yet, but it's something we're looking at doing, is the cockpit recorder. I know that Airbus on some of their products has made that almost mandatory, or made that mandatory, and it's something that we want to do in the future. It's something that will assist us from maintainers to find out what's going on with the helicopters, almost a real-time identification of what's happening with the helicopter. But it'll also help us be better aviators, better operators of our helicopter. So it's another safety feature that we're trying to figure out how to get there. But it's something we want to do in the future.
Thanks. And another question just popped up related to the CRFS kit.
Okay.
Does the new fuel system, does it have any effects on the weight or fuel capacity?
Fuel capacity, no. I believe it's going to be a bit heavier, to the point of about, I think the last calculation was about 3 to 4 pounds overall heavier than the previous aluminum tanks. But the way the tanks have been designed, no, the fuel capacity will be exactly the same.
Okay. I don't know how much detail you can go into about it. Also related to the new fuel system. Can you explain how the crash resistance works on it?
Sure.
What being implemented?
Sure. So we went with a bladder top system that's covered with carbon fiber, and we've got all the various certification bases covered with regards to lightning strike and seepage or slosh and vibe. The majority of the 50-foot drop test that we've successfully completed, the bladder will take the majority of the impact, but the carbon fiber shell absorbs a lot of the energy initially. So those two working together seem to be a pretty decent combination for what we're going to do. Again, we wanted to make sure that it has the same fit and function, so that we can retrofit to the rest of the fleet, but it will have the same the fit to the helicopter in the same geometrical shape as the original tank. It's just its construction is substantially different.
And I was told there's one more question about to be transmitted over to me.
Okay.
back to the, about to say EVAs, the electronic displays, glass
Yes.
cockpit. You mentioned, I think you mentioned a couple of items, but the question came in is, what parameters are going to be monitored by the new system?
Initially it'll be the parameters as outlined, in the do not exceed. So, overspeed on startup, that I believe that's in the, I couldn't reference it directly, but I believe it's in the pilot operating handbook. There's also cautions in the pilot operating handbook about, startup overspeed to make sure you don't exceed a certain RPM. But the rest of the parameters will be the normal things that we would look at, rotor speed, things like oil temperature, oil pressure, either getting too high or too low. Those are the initial parameters that we want to touch on. Things where the helicopter within its approved operational parameters, we want to monitor those and be able to record those kind of things within our display.
Thanks, David. And let's see. Oh, one more question. This actually has to do with the X-ray of the tail rotor drive shaft. I believe it's the tail rotor drive shaft is what they're talking about, the X-rays.
Yes, sir.
Do you happen to know, like, generally what the cost per hour is for the X-ray? And
I don't. It was. I think our X-ray was less than. I don't know. It was not. It was inexpensive. I don't have the exact dollar amount for what they charged here locally, but it was relatively inexpensive. Again, it was very quick, and I can get back to whoever's asking that question. I can at least give them some information of who used and the actual cost and the time frame. Again, I know we had it turned in one day, but the cost was minimal.
And following to that, is performing the X-ray required, mandatory for the drive shafts?
No, what we want to do is, because we're only seeing this in certain operator, right, and we're not seeing this worldwide, and we have enough of a number of drive shafts we've X-rayed, is that we want the operators to, carefully look at their drive shafts whenever they do the next scheduled inspection, where the drive shafts would be removed from the airframe. And then if they see any anomalies with the drive shaft, that would be the next time we would want them to, perform the actual X-ray inspection. So the initial is the same way we found the drive shaft that we're dealing with now. It initially came about based on a visual inspection. And so we want to start there with a visual inspection, with carefully looking at the drive shaft. And again, if that produces any anomalies, then we will want to take it to the additional steps necessary to ensure there's nothing wrong with the drive shaft.
I keep forgetting to hit the unmute button there. Look down, it's like, oh, where is it? Sorry. And I think we have one final question. Sorry. The allergies down here in Fort Worth.
Yeah, I'm right here. I'm over in Fort Worth. Yes, I understand.
At least, hopefully, all this rain cleared it out.
Yep.
But this last question is related to the elastomers. Are any checks done to assess degradation of elastomers in the dampers, or are there any visual indications?
I think there is and I didn't really address that in the HMI as part of the presentation, but I believe in the HMI, there is a test that you can actually do to validate that the elastomeric is doing what it's supposed to do. I can follow up with that also. The biggest thing we see those is that the elastomerics are usually doing what they're supposed to do. There's either a bolt or a bearing issue with the way that they're attached, and that has been the issue in the past. The elastomeric's doing what it's supposed to do, but you still have lead lag issues, and it's really coming down to ensure that the bearings that the dampers are attached to on both sides are good bearings. But again, I believe there is something that HMI that gives you a basic test for the elastomerics. I don't have it in front of me, so I can't really speak to it, but I believe there is something in the HMI that outlines the test of the elastomerics.
Well, thank you, David. And that's all the questions we have received for today. Do appreciate all the information you provided. lot of great information and idea of some things to come for the 269. Again, thank you for presenting today.
Thank you very much. I appreciate the Schweitzer being a part of this great seminar. It's super important for our industry, and thank you for having us.
Thank you. And for all participants here, we'll be taking a 5-minute break. We will start with the next presenter at the top of the hour. Until then, we'll share a couple of safety videos for you. Thank you.
Years ago, as a Navy pilot, I was asked to perform a night vertical pickup from a submarine. On the sub was a sailor with appendicitis. A night vert rep to a submarine is a classic example of operational necessity. That is what the military defines as a mission so important that it is worth the risk of loss of both aircraft and crew. If a military pilot declares an operational necessity, he or she can expect a board of inquiry upon returning home. I knew this full well, weighed all the parameters, and made the decision to proceed. Fast forward to a military retirement in a new position. As part of the job, I recently spoke with survivors of civilian medical helicopter crashes. Their stories described a culture very different from the military. Even though they have their rules and launch criteria, they certainly aren't followed with the same rigidity. Story after story told of the 3 to go, 1 to say no rule being ignored without administrative repercussions. Then there were the stories where disregard of this rule led to fatal crashes. This culture is something I'm not used to. The rank structure in the military and consequences outside of physical exploration are always in the thought process when making cockpit decisions. This is one time where I believe the civilian world could learn something from the military. Follow your rules. They are there for a reason. Investigate when they are not followed. Before every flight, think about the consequences and if the mission is really worth it. Pilots, while the ultimate decision to launch and continue a flight is usually yours, don't be afraid to ask for and weigh your crew's input. So often we learn from failure, but it is much nicer to learn from success. Incidentally, we did successfully complete the night vert rep. I also faced that board of inquiry, and they all agreed that they would have done the same thing. It was a good feeling knowing that we had saved a life and had done it within the rules.
I remember thinking as my hand reached for the door, should I try to run or stay in the aircraft? It was a typical night, busy but not overly so. Another call, ICU to ICU, fairly routine. At the receiving hospital, we accidentally left the radio in the helicopter. That's okay, we'll get it if we need it. Link of complacency. After a long walk to ICU, we gave report, charted, and assisted with care while socializing. In the distance, an overhead page for a trauma alert. Is that trauma coming by air or ground? Should we call to see if we need to move off the pad? No, Medcom will notify us. But we don't have our radio. That's okay. They'll use our pagers to get hold of us. Link of assumption. What we didn't know was that because we had been in ICU for a while and Medcom was busy with multiple other transports, our presence on the helipad was forgotten. Link of absent-mindedness. Our walk-arounds completed and nearly secured in our seats, we heard the sound of a helicopter on final behind us. My partner, staring at a landing light, said, "Hey, do they see us?" Then louder, "Do they see us?" My heart's pounding. I can't see them. There's no place to go, no time to call. Do I run or stay? Suddenly, a helicopter passed over us, doing a go-around. The other pilot, during his reconnaissance of the LZ, saw our taillight and went around. He said it was not even close. He was in control the whole time. But our perception was of danger, and what could have happened scared and sobered us. The pilot's awareness broke the chain that we were building, a chain building toward disaster, forged with the links of complacency, assumption, and absent-mindedness. A chain I don't ever want to forge again.
I gotta break the chain. Please help me break the chain. I wanna break the chain. Break the chain. Break the chain. Break the chain.
Yeah, welcome back. Now up to our next presenter. Offering the maintenance seminar for Bell Helicopter is Bruno Santon. An aircraft maintenance engineer since 1998, he has worked for Bell Helicopter as a product support engineer within the Light Group since 2003, providing support to Bell aircraft owners, operators, and maintainers worldwide. So Bruno, over to you.
Thank you, Stephen. Now that you know who I am, welcome to all of you to the Bell presentations on light and intermediate models. In today's presentation, I will go over the following topics. There will be an introduction. I will talk about the 206 series, 47 series, the 505, and the 429 model. There will be a question period at the end of this presentation. While I will be going over those different models, I will also address some service directives, maintenance tips, health and safety issues, and recent improvement that we have done on those different models. On this slide, you could see the product support light and intermediate team. So here we could support some questions on avionics, mechanical issues, and structural issues. We also show on this slide the Singapore team. So since 2018, we have now 2 locations where we provide product support to the commercial customers. The first location is Mirabel, Canada. And since 2018, we open up an office in Singapore. Singapore will mainly support the Asian and European customers, commercial customers, and we'll still have our office in Fort Worth, Texas. This office will take care of military and ex-military helicopters. Let's talk about the 206 series. So we stopped manufacturing the 26B3 in 2010. So between the AB models, we have built 4,687 of those models. And the item ship is serial number 220 with more than 38,000 hours. For the 26L series, from the straight L up to the 26L4, we stopped manufacturing the L4 in 2016, and we have built more than 1,926 of those 26L series. And the item ship is serial number 45597 with more than 41,000 of hours. 26 alert service bulletins. So we recently released these ASBs for the 26A and also the 26L series because we have received reports that on some of those models, the bonded adapter on the tail rotor drive shafts was debonding in flight from the shaft. So while this was occurring, it was causing the loss of tail rotor authority. So those ASBs are going to ask you, if you have bonded dry shaft, to do a visual inspections of the bond line. So you have to make sure that there's no crack, no missing bonding material, and there's no corrosions around the bond line of those tail rotor dry shafts. If you see one of those issues, the tail rotor dry shafts, the bonded dry shafts, needs to be replaced prior to next flight with either riveted dry shafts or a serviceable bonded dry shafts. Now, if you don't see any of those issues on that bonded line, what you need to do is to draw a line between the adapter and the drive shafts and to do a proof load test. Once the proof load test is done, you still need to do another visual inspections of the bond line to make sure that nothing went wrong, that you don't have missing or cracked adhesive around that bond line. Now, to do the proof load test, you have to use a breaker bar and a torque wrench. So the breaker bar is going to be installed here on this adapter in front of the oil cooler. And the torque wrench is going to be installed on the last adapter just in front of the tail rotor gearbox here. Now, if you have a 26L1 or an L3 that have accomplished Service Instructions 2052, and if those models have bonded adapters, and if you have one of those 26L4 in your fleet, the forward adapter dimension is going to be different. So we just revised the ASB for the 26L series with revision B, and in revision B, we provide you on how to make that breaker bar. So this is a work aid that could be locally manufactured, and this breaker bar will have both size adapter on this bar. So you could use this breaker bar on any 26L series helicopters. Now, when you are doing the proof load test, you have to make sure to protect the helicopter. But also remember that at any given time, while doing the proof load test, one of those bonded adapter could let go. So make sure not to hurt yourself while doing this proof load test. And you will need to do this proof load test at every 300 hours or 12 months until you have replaced all those bonded dry shafts with riveted dry shafts. 26 series operation safety notice. So we released this operational safety notice because we received some reports that in some cases, passengers were interfering with the flight controls. Like if you have a passenger sitting on the left-hand seat, the crew left-hand seat, then if you have dual controls, we recommend that you remove those dual controls. And you could also get an STC. Those are aeronautical accessories STCs that you could see on this picture here, these pictures. And you could secure the pedals using a locking pin or a placard that will be installed in front of the pedals. These, again, are aeronautical accessories. The bottom picture shows the 429 model. Like that placard will prevent the passenger to put his feet on the pedals. So whenever you are doing or getting passengers on board of the helicopter, make sure that they have a good debrief, that they know how to enter and exit the helicopter, that the pilot provide them with a debrief in case of an emergency on what to do, and that the passengers also know how to use the seat belts. And if you have any loose equipment, that this loose equipment will be secure, such as bags or any electronic devices during the operation of the helicopter. 26 series maintenance tips. So whenever you are doing the main rotor head greasing, we recommend that you remove the vent on top of the main rotor grips. So this vent here needs to be removed. And whenever you are pumping the grease inside of the main rotor grips, make sure to pump the grease slowly, because using Tixosin is much thicker than Mobile 28, and you may damage the excluder seal. And this is an example of the excluder seal being damaged, in the field. And once it gets damaged, then the grease will be slinging out of the main rotor grips. So remember, remove the vent, pump the grease slowly with the hand grease gun, and reinstall the vent once the lubrication of the grips is done. And this is applicable to the 206s and the 505 as well. 206 health and safety. Here we're going to see a video of, and pay attention to this gentleman closing the door of the hangar. So this man was very lucky. He could have walked towards the helicopter. So we recommend that the hangar be inspected and maintained, as well as the helicopters, and also your tooling and any equipment that you're going to use to maintain the aircraft or the helicopters. .26 series improvements. So we have done a lead the fleet on the Bell part number TT straps. That lead the fleet lasted about 6 years, and we were able to increase the life retirements of the Bell part number TT straps. Today, the life retirements of the Bell TT straps is 1,200 hours or 48 months. And we were able to do this by collecting data. So we had some TT straps part of that lead the fleet, and those TT straps were inspected at different intervals. So we were getting the data. Once we had enough data, we submitted the data to the authorities, and then they approved the extensions or the improvements on the life retirements of those Bell TT straps part numbers. 47 series aircraft. So the first 47 that we built was the 47 with the analog gauges, the wrong gauges. And we built 1,154 of those 47s. Item ship is 53,190 with more than 27,000 hours. Then we started building the 47GX. The GX was the first 47 with the Garmin suites. And we built 274 of those aircraft. And the item ship is serial number 54336 with more than 6,000 hours. And then we started building the 47 GXP. The GXP, or the P, means power. So the engine manufacturer was able to improve some of the internal component of the C47B/8 engine to provide more power. So we built 196 of those aircraft. The item ship is 54,620 with more than 2,700 hours. And today, we are building the 47 GXI. So far, we have built 80 of those GXI. The item ships is 54,813 with more than 660 hours so far. Let's see a little bit more on the GXI. So the GXI has a new engine. It's got the C47/E4 engine with dual FADEX. It also got the new Garmin G1000H NXI avionics suites with crisper displays, and all the equipment are going to be faster on the boot up of the helicopter. This new engine also had a new fuel pump power unit, also a new fuel metering unit, and we changed the SIFA filter for a new scavenge oil filter called the SOFA. And this GXI doesn't have an external airframe fuel filter anymore. The fuel filter is part of the engine. And we were also able to replace the throttle cable by an electrical linear variable differential transducer. 4.7 alert service bulletins. So we released this alert service bulletin to address a production issue. First, this upper hole on some newer 4.7 is no longer required. So engineering came up with the solutions to plug the hole with one of those metal caps. However, this metal cap could have been installed on the opposite direction, meaning towards the engine intakes. So if you have one of those affected 4.7, you need to check if you have this metal cap. If the metal cap is present, you have to remove it and install a bolt, nut, and washers to plug this hole. 4.7 technical bulletins. This technical bulletin was released a few years back. However, if you have a 4.7 and you didn't do this technical bulletin or install that fitting with the screen, we highly encourage you to install this new fitting with that screen, because that screen may help to prevent any blockage of the freewheel oil supply system. And in the next slide, I'm going to show what happened when the freewheeling unit oil supply line can be blocked or partially blocked, what could happen. So we are currently working also on similar technical bulletins for the L and the B series. So we could have one of those fitting with a screen like you see on this picture. So these are two examples or two documented example of the freewheeling unit being partially blocked during operation or blocked during operations. So on the first event, the pilot started the helicopter. This is the first event. And when he rolled the throttle from idle to 100%, the freewheeling unit clutch slipped, and then it re-engaged at some point. Now you could imagine that when the clutch slipped, the main rotor started to slow down, and the tail rotor also started to slow down. And when the clutch re-engaged, now you had all the power coming from the engines, because the engine didn't slow down, only the clutch was spinning. And then the mast severed, and this is a picture of the mast. This is the clean cut of the mast, and the tail rotor drive shaft also severed. On the second example, they were doing auto rotation training. And on one of the auto rotation practice, the clutch slipped, and then the mast severed, and the pitch links ended up twisted around the mast. Now we had other reported events, and on all of these reported events, the material that was found blocking or partially blocking the oil passageway was not coming from the transmissions or the freewheeling unit. So anytime that you are undoing this line, removing the line, reinstalling this oil supply line, make sure not to introduce any FUD into this oil system. .47 series information letters. So we just released this information letter to make sure that all 4.7's operators are aware of this new global alternate means of compliance, this new AMOP provided by Transport Canada. So this AMOP is saying that if you are installing this new left upper longeron, the 105, per this technical bulletin, then this will be a terminating actions to the ED and also the ASB that was revised not too long ago with revision D. And it also says that the AMOP, this 105 is an alternate to the previous left-hand longeron, the 237B longeron that was installed per this technical bulletin. And also the AMOC is saying that during production on those newer 407s, we were installing a -103 upper longeron, which is also a terminating actions to the ED and the ESB as well. We released this information letter to make sure that all of the 407 and also 505 operators are aware that we want or we recommend that the maintenance card be installed or left installed during the aircraft operations. This maintenance card needs to be installed on the multi-function display on the upper slot. And what it's going to do, it's during operation of the helicopter, this card will collect some data. So you may need to go back to this card to collect some data in order to do some troubleshooting. Or if you are contacting product support to help you out during troubleshooting, we may ask you to go and get some specific files from this maintenance card. We also recommend that you remove this card from time to time, download the information to a computer to make sure that there's no excess data on this card. And whenever you need to go back to this card to find out some specific files, that is going to be easy to do. And if we are asking you to get some files, that it's also going to be easy for you to get to those files. 407 series maintenance tips. So in this case, the pilot was doing a pre-flight check. So he turned off the hydraulic power, and then he did his checks. When he turned the hydraulic power back on, the hydraulic power was not coming back because this wire here was chafing on the connector of the solenoid, providing power to the solenoid. So this is the reason why power could not be turned back on. So upon the investigation, anyway, they found this wire broken. And whenever you are either adding a wire or you are doing any type of work on the circuit breaker panel, make sure that there's enough space between the wire bundles and the connectors. You could secure the wires with snake skin or tie wrap as seen in this picture. 407 health and safety issues. So in this report, the customer jacked up the aircraft and they left the aircraft on jacks overnight. The next morning when they came into the hangar, the aircraft was laying on its side and it was held in place because of the main rotor blades. So whenever you are jacking the helicopter, make sure that you are using the correct size jack for the aircraft, that the jacks are not leaking, that the valve is closing and opening correctly, and that once you have reached the correct height, that you have locking collars on the stem that you could secure the stem from not coming down overnight. And this will ensure safety to the personnel working around the aircraft and that the aircraft will not fall off the jacks during the day or during the night on its own. 407 and 26 series have or could have impact resistant windshields. This is an STC offered by Aeronautical Accessories. These impact resistant windshields are made of polycarbonate material. On this picture here, the object thrown at VNA speed was a 2.2 pound object. So the windshield was able to deflect this object and to return to its original state without breaking. This is a good safety enhancement for the crew and also the passengers of either the 407s or the 26 series aircraft. If you want more information on this kit, contact Aeronautical Accessories directly. 4.7 improvements. So over the years, we received reports that corrosion was found on the connector of the airframe fuel filter head. And we also received reports that the press to test button was hard to press, or in some cases was missing after a flight, or fuel was leaking out of that press to test button. And other cases, you could remove the press to test button by hand. So we worked with the manufacturer of the airframe fuel filter, and they are coming out with a new fuel filter head. And we are also working on the technical bulletin to introduce this new filter head, which will have improved connectors or connection for the connectors. It shouldn't corrode anymore. And they also enlarge the press to test button, and it should not be movable, like you could not remove it by hand anymore, and it shouldn't leak on this new fuel filter head. We also received some reports on the 4.7 and the 2.6L series that sometimes after a flight, the litter door handle was missing. Or if you were to go and open the door, that in some cases the door was falling off. The only thing that is keeping this handle attached is that circlip. And as you could see here on the housing, that circlip after time in service may damage the housing. So we worked with the manufacturer of the litter door handle, and they are coming up with improvements. So what they're gonna do is they're gonna add a cutter pin into the door handle shaft, so the door handle won't be able to leave the helicopter or to fall off in your hand once you open or close this door. They will also add a larger washer underneath of the circlip to prevent damage to the litter door housing, or litter door handle housing, I should say. 505 aircraft. So up to now, we have built more than 320 of those 505 aircraft, and there's about 295 of those aircraft active today in the field. The fleet hour has reached more than 53,000 hours, and the I-time ship is 65,083 with more than 1,617 hours. .505 alert service bulletins. So we just released this alert service bulletin because we received reports that when the customers were doing that 12 months inspection of the mast pole, they were finding that the mast nut was loose. So we did an investigations, and we find out that the manufacturer of the flap restraints, in some cases, was adding a clear top coat on top of the primer. So after being in operations, after a few hours of operations, the clear top coat was able to break off, causing the loss of torque of the mast nut. So that ASB is providing you with the method on how to remove the clear top coat, which is very simple. You take some solvent and some abrasive paper, and then you can get rid of that clear top coat if it's present, and then reinstall the mast nut per the maintenance manual. We also released this alert service bulletin to address a production issue. In some cases, the installer have installed too long screws on the firewall, and in some cases, the screw was able to touch the upper surface of the truss lug. So that ASB is providing you with some gaps that you need to have between the screw and the upper truss lug. And if the gaps is too small, then you have to replace the screw. Or if the screw is touching this upper surface, then you need to refinish the surface protective coating of the truss lug. We also released this alert service bulletin like a year back. And the reason why we did that is because we received reports that on the swash plate assembly, some of the bearings may have spin or rotate inside of the bore. So we worked with the bearing installers and they have improved their instructions and also their tooling. At this time, what we want to know is that if you have a 505 and you are seeing those bearings spinning or turning inside of the bore, send us a report. Tell us the serial number of the aircraft, the total time of the aircraft, and send us pictures of the bearing and showing that they spin or turn inside of the bore, because we want to know if this issue has been resolved or not. 505 technical bulletins. So we just released this technical bulletins to introduce a new software update for the 505. That new software will take care of some nuisance faults that we have received reports on. So we were able to change the time delay before declaring a fault. So in some cases, we added like up to 5 seconds before declaring a fault. This technical bulletin also introduced a new wiring change for the ECU failcast message. So you will need to change the wiring in order to change the logic. So whenever you're going to see one of those ECU failcast message in flight, make sure to follow the flight manual section 3 emergency procedures. And we strongly recommend to do this software upgrade as soon as possible to get rid of those nuisance faults and also the wiring change to get rid of the ECU failcast message that was coming or reported in the past. We released this technical bulletin to introduce a new vented cap for the hydraulic reservoir. What we find out while doing some cold weather testing is that if you had the original orange cap installed, and if the helicopter was parked outside for more than 1 hour at minus 20 degrees Celsius or minus 4 degrees Fahrenheit, you could not start back the helicopter. So if you are doing any cold weather operations, make sure to have the new vented cap, which is black in color, and you could start the helicopter or operate the helicopter at minus 40 Celsius or minus 40 degrees Fahrenheit, regardless of the time that the helicopter was parked outside. And you can get this new cap under warranty until November 25th of this year. We also released this technical bulletin to address an issue. Like we received reports that when the 505 was parked outside or parked for a longer period of time, the oil from the engine oil tank was able to drain down into the engine accessory gearbox. So this technical bulletin is introducing a new check valve to prevent this from happening. Because we know that in some cases, previously of this check valve, some pilots or maintainers or technicians were looking at the side glass, couldn't see any oil in the system, so they were adding oil to the tank instead of doing the engine cranks. So you could do up to 2 engine cranks, and what it's going to do, it's going to take the oil from the engine accessory gearbox and return it into the engine oil tanks. So then you will know if you are missing or you have just enough oil to do your operation. If you want to know more about what happened when you overfill the engine oil tanks, go to this information letter, 505-1702. It's going to give you some example of what happens if you overfill this engine oil system without the check valve. 505 information letters. So we received reports that while doing cargo hook operations, operator noticed that the radar altimeter was doing a self-test during the cargo hook slinging. So Aeronautical Accessories came up with a modification, a wiring change, to make sure that if you are doing any cargo hook operations, that the sling or the cargo hook won't interfere with the signal cones antennas of the radar altimeter. So it will inhibit the radar altimeter to do self-test during flight. 505 maintenance tips. We have received reports of a premature wear on the shaft of the hydraulic pump. So this shaft is currently located between the hydraulic pump and the transmission oil pump. And we know that this shaft doesn't engage far enough over the splines of both pumps. So engineering is currently working on getting a longer shaft for the hydraulic pump. And whenever you are doing the lubrication of this shaft, make sure to lubricate both ends of the shaft with this specific grease. Boosted belt cranks, we received reports that red dust was found around the bearing of the boosted belt crank. So the red dust is actually coming from the bearing. However, if you see this red dust, it doesn't mean that you need to replace the boosted belt crank. The only criteria to have the boosted belt crank replaced is that if there's bearing axial play or radial play, if the bearing play is exceeding the limits. We know that we don't have those limits published in the manual so far. If you are finding any play, send us a report with what you're actually seeing as far as axial and radial play, and we will tell you if the bearing is serviceable or not. We are also currently working on getting new bearings and new belt cranks for the 505, and those should be ready by the end of 2020. The 505 and also the 47s are using a collective pitch transducer. Usually we call it the CPT. The role of the CPT is to send signal to the engine fuel control unit based on the collective positions and its rate of change. So what we had received so far as reports is that in some cases, you could see some engine parameters oscillations, or even in some cases, yaw oscillations of the helicopter. And this is caused by that CPT. So if your pilot is reporting seeing yaw oscillations or engine parameters oscillations, check out that CPT. We are currently working with 3 units to try to determine what is the root cause of those CPT failures or recent CPT failures. 505, health and safety. So we released this technical bulletin to enhance the safety of the ground personnel working around the 505. What was noticed is that the horizontal stabilizers outboard corners are very sharp. So this technical bulletin wants you to cut out the corners and to make a radii of 160 degrees. And this is to prevent further injuries of the personnel working around the 505 aircraft. 505 improvements. So we are currently working on a kit where it's called a pilot movable ballast kit. So the pilot is going to be able to move weight either from the tail boom sections to the cabin section in order to meet the specific center of gravity based on the specific missions that he has to accomplish. So this kit should be ready by the end of 2020. Starter generator brushes on the 505, we have received reports of premature failure of those starter generator brushes. So we worked with the starter generator manufacturer, and they came up with longer life brushes. Now, if you are seeing those premature wear on the brushes, what you need to do is to submit a warranty claim for a replacement starter generators. Because as you know, we do not have any instructions on how to replace those starter generators in any of the Bell manuals. The 429 models. So the 429 fleet is up to more than 370 of those aircraft in service today. The fleet hours is more than 400,000 hours, and the time ship is 57006 with more than 5,657 hours. 429 alert service bulletins. So we just released this alert service bulletins for the main rotor expendable blade bolt, because in some cases, some of those expendable blade bolts do not have that swaging dimple. So you have to check for the presence of this swaging dimple. If the swaging dimple is missing, you have to remove the expendable blade bolt, open the bolt, and then do a test using a blunt object. You need to push on the pin. This is the handle pin. And if the pins move, like you see on this picture, then you need to replace this expendable blade bolt prior to next flight. And also make sure that you understand what is the swaging dimple versus the hardness checks dimple. There are some examples in that ASB to show you what is the hardness checks dimple compared to the swaging dimples. We release also this alert service bulletin to make sure that all of the 429 operators with emergency flotation systems are aware of this Safran service bulletin. This service bulletin is providing you with a list of the different hosts that were mismanufactured. So what you need to do if you have one of those mismanufactured hosts is to take a tie wrap, which is about a foot long, and then check if there's any obstructions inside of that hose. And if there's any obstructions, then you need to replace the hose. But go back to this ASB, which have this Safran service bulletin attached to it for more detail on what to do. 429 technical bulletins. So we released this new technical bulletin to introduce a new flexible disc type coupling. So this new flexible disc type coupling is going to replace this grease coupling, which is located forward of the oil cooler blower. So when you are installing this new disc type coupling, you will also have to replace the aft adapter. We tried to get one of those flexible disc type coupling at the forward end of the shaft, like at the output of the transmission. But because of the angular motion of the transmission, we were not able to get one of those flexible disc type coupling in order to eliminate all the grease action that you need to do. So the only thing that you're going to have to do when doing this technical bulletin, you're going to have to remove and replace the outer coupling at this forward end location because of the new length in the when you add this new flexible disc coupling, there's a differences in length. So that new coupling is going to take the gap that you need to fill after doing or while doing this technical bulletins. And this technical bulletin will reduce the direct maintenance costs associated with the greasing of this particular grease coupling. 429 operational safety notice. So we released this OSN to make sure that whenever you are doing the 2-year flight inspections, the flight controls inspections, that you pay particular attentions to the bearing of the flight controls. You have to check for axial and radial play of the bearing, but you also have to check for corrosions, roughness of the bearings, and the stiffness in the bearing. So pay particular attentions to the flight controls bearings when you do that 2-year inspections. 429 health and safety. So we are currently working on a technical bulletin to relocate the left end fuel vent to the right end of the 429. The reason why we want to do this is because we received reports that passengers or the crew were able to smell some fuel vapor while in operations. And this is not on all 429s, but on some of the 429s. So this technical bulletin, once you have done this technical bulletin, then the passengers and the crew shouldn't be able to smell the fuel anymore inside of the cabin. Hangar protections. So whenever the helicopter is parked inside of the hangar, we recommend that you protect the finlets, the vertical fin, the stingers, the tail rotor blades, the antennas, that you protect them with some cushions or some material in order to prevent damage to those components, and also to ensure that personnel working around the aircraft won't get hurt by these surfaces. .429 improvements. So over a few years, we have worked with new bearings for the 429 tail rotor pitch change links. And we have tested those new bearings, the SKF Extended Life Technology bearings. And so far, based on the customer data, those bearings are meeting engineering expectations. And those bearings are currently available in Bell Spares. You could order those new tail rotor pitch links, these 105 or the 107, and you will have the new bearings installed on those pitch links. Do you have any questions?
Hey, Bruno. Thank you for the presentation. A lot of good information there related to the Bell products. You did cover quite a bit of information pertaining to alert service bulletins, technical bulletins, and safety notices. Think about the impact-resistant windshield kit. Regarding to that, is the used a 2.2 pound, 1 kilogram, I guess, replica of a bird to meet the, I guess, comply with Part 29 bird strike requirements for the windshield. It's just for the windshield only, right?
Yes, those are for the main windshields, left and right, yes.
And that's a kit that's available to operators.
Yes, it's an STC offered by Aeronautical Accessories.
Okay, thanks. Let's see. Another question we have, it's related to the Bell part number TT straps.
Yes.
New life limit on those new straps?
So the new life limit is 48 months or 1,200 hours, whichever comes first. And this is the most extensive life that we're gonna get out of those TT straps.
Wow. Interesting. Had another question here. We're trying to figure out what the intent of the question, so maybe it make more sense to you.
Okay.
Yeah. It had to do with at the beginning of the presentation, there's a mention about a dream panel for the future. The question is about updating any dream panel that's incorporated. Will the operators be rewiring, any rewiring required for the new panel, or is that something the OEM will be helping with?
I'm not sure that I understand this question, Scott. I don't think I spoke about any drains panels or.
Yep, we maybe just misunderstood the question that was submitted to us. It was through the YouTube, so.
Yeah, or maybe you
channel.
could send this questions to us later, and then we could respond to it later.
Okay, yeah, we'll coordinate questions. Let's see. Another question is, it's just a curiosity question. Somebody was asking if they get how did they get hold of video of the hangar door falling in?
Now, this is like when it occurs to the customer sent the video. There was a camera, inside of the hangar, and the customer was able to send the video to our customer support engineers in that locations, and then the engineer sent us the video so we could use this video during conferences like this one to make sure that not only the aircraft needs to be inspected, but also your work environment, your tooling, and your equipment that you're going to use to maintain the helicopters or the aircraft.
And I guess pertaining to the question about the video, will participants be able to get copies of the presentations or videos you presented today?
We can provide the presentations. However, I don't think that the video is going to work. I think it's going to be a standstill image, or you're only going to see the image of the box and the movie reel. You're not going to have the video. I'm sorry, but
No, whoops. Okay, I will make sure I wasn't on mute again. I try to mute it every time after I ask questions.
Yeah.
Any noise will just really come from your speaker and everybody will cue into you. Let's see, I have another question that came in. Back to the TT straps.
yes.
The 48-month life limit on there, is that 48 months of operational usage, or could it also include shelf life?
No, it's 48 months. As soon as you install one of those TT straps and the rotor start turning, then the 48 months start at that time, because there's already some preload on those the wires inside of the TT straps. So this is when the calendar time starts, when the rotors start turning for the first time.
Okay, so it's pretty much install time.
Yeah, install and once you start turning the rotor.
Okay, another question, I mentioned the ASB's technical bulletins and operational safety notices. Could you briefly explain the differences between the ASB, the TBs, and OSNs?
Yeah, the ASB, based on Bell helicopter, those are mandatory service directives that you need to do if you have an affected component, or if the helicopters that are listed are the one affected by that alert service bulletins. And then the technical bulletins, those are mainly customers' options. Customers could improve their helicopter based on the technical bulletin. And this will also ensure that the customer will keep his aircraft to the utmost, with the utmost recent upgrades and parts available in the field. The OSN, those are operation safety notice. So those are based on operational issues that were reported to Bell or to the authorities.
Okay, thanks, Bruno. And related to ASBs,
Yes.
a question that came in about ASBs. Are they eligible for warranty coverage, or is there a barrier somewhere?
Yeah, it's part of the ESB. Usually it's gonna be on the second page where we're gonna say if you're entitled to get some warranty compensations. So the warranty compensation, the warranty statement will stipulate what you are entitled to. Sometimes we do, sometimes we don't provide warranty based on the nature of the issue.
Yeah, so it would be listed in the ASB itself.
Yes. Oh, yes.
Let's see. I had a question about the collective pitch transducer.
Yes.
And the question is, what other issues besides yaw oscillations have you found with the failure of the collective pitch transducer?
At this time, I'm not aware of, except for engine parameter oscillations, yaw oscillations. I don't think that you could foresee any failures of that CPT without of those two parameters. I don't think that there's any others parameters that will lead you to look at that CPT.
Okay. And another question about the tail rotor pitch change link, the bearings.
Yes.
How much more life do you get or expect to get with the improved bearing for the tail rotor pitch change link?
This is a good question. I don't have the number on top of my head at this time. I wish I would have remembered this number, but I will imagine that it will meet the intent of the, that the bearing would work up to the next inspections. I believe that those bearings should be inspected every 800 hours or so. So I will imagine that these bearings will meet or exceed this scheduled inspection.
And another question back to ASBs again.
Yes.
The question is the ASB equivalent to an FAA-AD per Bell policy?
We believe, or our intention is that when we publish an ESB is that operators are gonna do that alert service bulletins, but we know that in some cases, operators are gonna wait until there's either Transport Canada or FAA ADs or CASA ADs. So it will depend on where the helicopter is located and the rule of that country. But Bell expects that all the operators are gonna do the alert service bulletins that are issued by Bell.
Thanks, Bruno. And yeah, just I guess I can say, come from the FAA side and working with ADs a lot, that the AD is actually what is regulatorily required by the
Yes.
FAA. The ASB is, in general, is what we base our ADs on. We see an ASB and by an OEM, it's indicating that, yeah, there's a unsafe condition identified that at least the OEM has declared, yeah, that action needs to be taken. And we on the regulator side, we review the ASBs and really pinpoint toward what is required to address an unsafe condition in a design that may be found on other similar designs. So don't go into the AD side. I like doing this instead of hearing a lot of different things. But Bruno, I think that brings us to the end of the presentation time. Really do appreciate the time you took to present items that pertain to Bell products. I know a lot out there in the field and a lot of maintenance and operators that found interest in this. So thank you again for taking the time to present today. We really do appreciate it.
Thank you all for putting this event together, and thanks to all the customers that were part of this presentation. Thank you.
And get my screen back up. It doesn't disappear. And now we have approximately 1 hour for a meal break. Our next presentation will begin at the top of the next hour. That's 60 minutes from right now. So we'll see everybody back then. Thank you.